Hey, good morning, guys. I just wanted to first go over yesterday's assignment with you. Thanks. Appreciate you guys doing that. I know it's kind of a late assignment. Just had one of those crazy busy mornings. But, this one getting out definitely earlier to you guys. So um, hopefully, from what I saw, from what you submitted, I was really happy with that. I thought you guys did well. You noticed how you're going to solve the trig function basically like you would solve any algebraic equation. It's just the last step instead of that being it when we get to like sine x equals 1/2 or x equals 1/2. We're not done. Now it's, well, what values or what angles have a y value of 1/2? So that's just how you have to think kind of throughout the whole process here. Just wanted to go over a few of these with you before we do today's notes. And they were mainly the ones that involved factoring. Okay. So with number 3, make sure you look for a GCF there. And that GCF that I took out was a sine x. And what would be left would be sine x plus 1. You're going to set each of them equal to 0. And then the thinking is, okay, well, what angle has a y value as 0? The angle that would be at 1, 0, and the angle that could be at negative 1, 0, right? We're not sure. It's either one of the two. They both have y values of 0. This is 0, and this is pi, right? We said, okay, it is 2 pi, but we don't want to continue, give ourselves too many answers because we could continuously go around. So we're staying in this interval from 0 to 2 pi, right? Make sure you factor. If looking at this original problem is too much for you, just kind of ignore the cosines, and just kind of think of it like an algebra equation that you would have to factor. And then when you're done, when you get x equals 1/2, well, just throw the cosine in front of it, right? And think to yourself, where does x equal 1/2, or where does x equal negative 1? Okay. All right. Remember, when you take the square root of both sides in number 5 here, once we get cosine squared x by itself by adding 1 and dividing by 4, we got to take the square root of both sides, right? And when you do that, you'll always have a plus or minus, and that's what leads you to pretty much have all of a special angle. So in this case, all of the pi over 3's, right, were our answers. Okay. Lastly, in number 7 here, right, a little different, but you're looking at it, you're saying to yourself, all right, well, they both have tangent. Let me take out tan x, and I'd be left with 3 times tangent x minus 1 equals 0. At that point, take your factors, set them equal to 0, and solve. Right? So I added 1, I divided by 3. I got tan squared x, so I'd have to take the square root of both sides, which means plus or minus. And you would get this after you take the square root, which you then would have to rationalize. And that's where I knew it was, okay, root 3 over 3. All right. And then I said, well, what special angle has a tangent of root 3 over 3? And that's pi over 6. Okay. So my answers were 0 and pi, right? Because y and x, so y had to be 0, x could be plus or minus 1. And it was all of the angles that have denominator 6. All right, guys, so hopefully that helps. I attached this already in Classroom, so you could look at it. Definitely take the time to watch the video and go back and listen. All right, so now we'll move on to today's notes. Okay, so today's notes are going to consist of the same type of thing. We're going to solve these trig equations here, right? Just the same kind of concept as we went over yesterday, and as you just saw me going over with the answers. The only difference is instead of dealing with sine, cosine, and tangent to maybe start with, now you could see secant or you could see cosecant, but the methodology is still going to be the same. So our first idea here is, again, just ignore the secant to begin with if you want to. You just want to solve for x, get x by itself. So to do that, you would add 2 to the other side, right? And then divide by root 3. So you'd add 2 over. You would divide by the square root of 3. All right? And now you get this. So some of you are probably thinking, okay, well, the only difference is I now have secant, but we know that secant is just the reciprocal of cosine. So rather than think in terms of secant or cosecant, let me just think in terms of sine or cosine, because I think that might be a little easier for us. So I'll write this as cosine x And all I would have to do next would be just to take the reciprocal of this side as well. All right. So where or what angles have an x value of root 3 over 2? Okay, so what x values, or I'm sorry, what angles would have an x of this? And if you're thinking to yourself, well, special angles of pi over 6, then you're correct. All right. And then you'd say, well, we have a positive x, and x is positive in quadrant 1, and x is positive in quadrant 4. So my answers would be pi over 6 and 11 pi over 6. All right. Next example here has cosecant. So again, we're just going to solve for x. And then at the end, we know we're going to have cosecant, but we'll just take the reciprocal and make it sine. All right, so the first thing you would do here would be to get this cosecant x squared by itself, or cosecant squared x, by adding 4 and then dividing by 3. Right, add 4 to the other side, divide by 3. Okay, and at this point we don't have x yet, we have x squared. So what we would do, we would have to take the square root of both sides. Sorry, it's a little sloppy. Taking the square root of 4/3, you would get, let's see, we would get 2 over root 3, right? And I'm not really worried about rationalizing yet, because right now I know I have cosecant. So in other words, I have the reciprocal of sine. So let me just write cosecant now as sine x. And what I had over here, again, I didn't worry about rationalizing because I knew I was going to have to take the reciprocal. And once I have the reciprocal now, that radical is no longer in the denominator. All right, so what angles or what special angles would have a y value, right? Sine is y, of root 3 over 2. All right, and that would be pi over 3. And where is y positive? Well, it's positive up top in Q1 and up top in quadrant 2. So our answers here would be pi over 3, which we can call our reference angle, right? And then if we want to think of working off that x-axis as 1 more than or 1 less than, that whole idea here would give us 2 pi over 3 for our angle in quadrant 2. All right, so there's our answer. I got one more example for you today, right? And I kind of mentioned earlier, just if this is too much for you, just think of x squared minus x minus 2. A simple basic factoring algebra equation, but what makes it trig is the fact that there's secant in there, but you still solve it the same way, all right? So I'm going to factor this, right? There's no GCF. We're going to separate this into 2 parentheses. So it's going to be secant x, and it's going to be secant x over here. Right, 2 is a prime number, but we would think what factors of 2 could give us -1. We just got to basically figure out the right spot for the sign. So if I need a negative in the middle, a negative secant x, the 2 is going to have to be the negative. This is going to be a positive, right? And this is definitely set equal to 0. So we're solving. We would take each one of these factors, set them equal to 0, and we would solve. Now, I don't think you need to see me actually set them equal to 0. I think we're okay with the concept of getting secant x to be -1 and getting secant x to be +2, right? So we just solved for x, except we're not done. Our answers are always angles, and they're going to be, the angles that have these values. But instead of thinking right now in secant, let's make secant cosine. And this isn't necessary, but this, I think, certainly makes it easier for the most of us. The reciprocal of -1 is -1. And the reciprocal of +2 is 1/2. Okay, so what angle, all right, what special angle has an x value of -1? Well, if x is -1, that angle's right here. All right, so that's going to be pi, right? Angles that have an x value of 1/2, well, that's pi/3, and if they're positive, excuse me, if they're positive, they're going to be on the right side, meaning they're going to be in quadrant 1. And they're going to be in quadrant 4. All right. So I'll post, post the assignment for today. I'll give you some extra time to do it. Get this done. Watch the video and do the practice problems. And again, if these practice problems, some will still have sine and cosine, but some might have secant or cosecant. They're going to look very similar to what you just saw here. So just carry out the problem, and in the end, take the reciprocals, and then think about your answers. All right, guys. Hope you enjoy the day. Great job so far. Really appreciate all the effort. Hope everybody's taking care of themselves and doing well. All right, talk to you soon.